Hi everyone, welcome to Easy Math, making math easy. Let me wish you all a very happy new year before we go on to our video. Wishing you a wonderful year ahead. May this year bring success to everyone. So with that note, let's start our video without any further delay. So in this video, we are going to visit concepts on trigonometry. We've already seen the fundamentals of trigonometry. The introduction video is already over. Those who want to revisit it, please do go watch it again, note down all the formulas, and then continue with this video. So in this video, we are going to see more on the trigonometric ratios, the identities, the standard angle values, the application in everyday life, and many more things. So without any further delay, we are going to move on to our topic. We saw in a previous video that the ratio between the lengths of a pair of two sides of a right angle triangle is called a trigonometrical ratio. To know more about this, please do visit the previous video. The link will be shared in the description box. So we saw that the sine of an angle is equal to the ratio between the perpendicular and the hypotenuse of the triangle. And then cosine of an angle is the adjacent side of that particular angle by the hypotenuse of the triangle. And tan theta is equal to the ratio between the opposite side of the angle by the adjacent side of the angle. And then we saw the reciprocal ratios. The reciprocal of sine theta is going to be the cosecant theta, and that is the ratio between the hypotenuse and the perpendicular, that's the opposite side of the angle. And then the reciprocal of cos theta is going to be the secant theta, that is the ratio between the hypotenuse of the triangle divided by the adjacent side of that particular angle. And cot theta is the reciprocal of tan theta, and that is equal to the base, that's the adjacent side of that particular angle by the opposite side of that particular angle. With this, we are going to move on and see how to solve few problems. Let's solve one problem and see, given the measures of any two sides, how to find all the trigonometric ratios and how to find the all unknown angles and the sides. So the first question says that from the given figure, the figure is here, find sine A, cos C, tan A, secant C, and secant square A minus tan square A. Okay, let's start from the first subdivision. Let's see how to find out sine A. Now, we know the measure of two sides. The third side measure is unknown to us. But before we go on to this trigonometric ratios, you all know what theorem to apply to find the third side of a right angle triangle, isn't it? So we use the theorem, that's Pythagoras theorem. Yes. What does the Pythagoras theorem say? It says that the square of the hypotenuse, the measure of the square of the hypotenuse is always equal to the sum of the squares of the other two sides. So with that, we'll first find the measure of BC so that it becomes easy for us to find the value of all the T ratios. Okay. Since we are given the two sides, the third side can be found using this theorem, right? Okay. So AC square. Now, which one is the hypotenuse here is the question. I've always told you the side that's opposite to the right angle is the longest side, and that's called as a hypotenuse. So now the right angle is here, that's B. The side that's opposite to it is AC. So that is your hypotenuse. The right angle is here, that's B. The side opposite to B, angle B, that's AC, is going to be the hypotenuse here, right? So please be very careful when you take out the hypotenuse, okay? So now AC square, that's 13 square is equal to BC square, which we don't know. plus AB square, that's nothing but 5 square. So to find BC square, let's transpose 5 square to the other side. So it goes as minus 5 square. So you get 169 minus 25, that equal to 144. So when your BC square is 144, your BC is going to be the square root of 144. That's nothing but always the square root are going to be both plus and minus the particular number, right? If you square plus 12 also, you're going to get 144. Minus 12 also, you're going to get 144. But here in this particular situation, the length of a line segment cannot be negative, right? So we are only going to consider the positive value. So we are going to take BC as plus 12, right? Okay. So your BC is going to be 12. So is it 12 centimeters or something? There is no unit attached to anything because these are just parts, simplified parts. The units or the measure of the side is not given. Okay, so now let's move on. So we are going to start finding that whatever we have. Now we have the measure of all three sides. So let's see how to find the T ratio of the angles. Okay, now first thing is we are supposed to find the sine of angle A, right? So now what is sine of an angle? It's going to be the opposite side or the perpendicular to the triangle divided by the hypotenuse of the triangle, right? So the side that is opposite to A, because I'm going to find sine A, so everything is relative to the angle A now. So sine A, the side that's opposite to A is going to be the side BC that does not have anything in relation to A, that's opposite to it. So your 12 comes on the numerator divided by the hypotenuse. The hypotenuse of the triangle is never going to change. So that is 12 by 13, right? Okay. So now let's move on to the second subdivision wherein we are going to find the cosine of C. So cosine of an angle is always equal to the adjacent divided by the hypotenuse. Adjacent or the base with respect to angle C by the hypotenuse of the triangle. Now, what is the base of angle C? The side that's adjacent to it, that is nothing but AC by the hypotenuse. I'm sorry, AC is the hypotenuse. So, the side that is adjacent to C is going to be BC. So now let's move on to the second part. We are going to find the cosine of angle C. Now what is a cosine of an angle? It's the ratio between the adjacent side of the angle by the hypotenuse of the triangle. That is the base with respect to angle C by the hypotenuse, right? Now, which is the side that's adjacent to angle C? That is nothing but BC divided by the hypotenuse is going to be CA or AC. So we have to be very careful. The hypotenuse is also going to be adjacent to C, but you need to be very clear that AC is the hypotenuse. So the other side, that the other arm of the angle that makes that particular angle is going to be the adjacent side. Okay, so that's BC by AC. That is nothing but 12 by 13. Yes. So the sine of angle A is equal to the cos of angle C. Interesting, right? We'll learn all this later, why it is and all that in complementary angles. Okay. So now let's move on to the third subdivision. That is nothing but your tan of A. Tan A, tan of an angle is nothing but the side that is the ratio between the side that's opposite to it divided by the adjacent side, right? That is the perpendicular by the base. So that is nothing but what is the perpendicular? Where is the angle first? The angle is here, that's A. The side that's opposite to A is going to be 12 divided by the side that's adjacent to A is nothing but AB. Right? It's not AC because AC is the hypotenuse. Okay, so AB is nothing but the measure of AB, the parts, okay, is 5. So 12 by 5 is my ratio. Okay, so that's about the third subdivision. We are moving on to the fourth subdivision, that is cosecant C. Okay, so cosecant C, I'll write it with green color so that you don't get confused with tan A and cosecant C. Now, what is cosecant C? Cosecant theta or the cosecant of an angle is the ratio between the hypotenuse and the opposite. That's nothing but the reciprocal of the sine ratio, right? Okay, so now what is the hypotenuse? Hypotenuse is never going to change. That's going to be AC. And what is the side that's opposite to C? That's nothing but AB. So your cosecant C is going to be 13 by 5. Okay, so now we are going to move on to the fifth subdivision that I will write it with a different color. So let me choose this rainbow color. So to make the board look really interesting. Okay, so mathematics is very colorful, right? So let's use a colorful pen to solve this particular fifth subdivision. Now secant square A, what is secant ratio? It is the ratio between the hypotenuse and the adjacent side, right? Okay, now the square. What does the square mean? It means that secant the whole square, secant A the whole square. That is, the ratio is getting squared here. How do we read this? We read it as secant square A. As however it is written, we are going to read it. Secant square A minus tan square A. Okay, it's basically the square of the ratio. Now tan A. What is tan A? That's going to be opposite divided by the adjacent, and there is a square on top, so we are going to square it. Okay, so what is the hypotenuse here? It's 13 parts divided by the adjacent. The adjacent of what angle? C. The adjacent of C is going to be 12. So whole square, I'm sorry, it's not C, it's A. It's A. Secant square A. So what is the hypotenuse? It's never going to change by the adjacent. Adjacent to A is going to be 5. I'm going to square it minus opposite. Opposite of A is going to be 12 and divided by the adjacent is going to be the same 5 and I'm going to square it. Okay. So now how to solve this? Let's quickly erase this part and use the whiteboard to solve this. So now this is nothing but I'm going to simplify this. So this is 169 divided by 25 minus 144 divided by 25. Okay. So if the bases are same, what do? When you subtract two fractions with the denominator the same, you just need to subtract the numerator and put the common denominator, right? So 25 is going to be the denominator of the solution too, and 169 minus 144 is going to be 25. So 25 by 25 is 1. Okay, so I would like to add on something here. What is a square basically? Exponents or the powers usually tell you that you need to repeatedly multiply the base so many number of times. So my power is 2. I'm going to multiply the value to itself twice. Okay, so I hope you all remember all this, right? So we will anyways visit all that. No worries. And with every topic, I'll be discussing all the basics also so that you understand the concept properly. So I hope you understood all this. So given these two measures of a right angle triangle, we were able to find the third measure. Not only that, we were able to find the P ratio of almost all the angles that are here, right? That was interesting, right? So we will solve one more problem. Let's move on to the next question. The question says, in rhombus ABCD, diagonal AC is equal to 18 centimeter. The angle between the diagonal BD and the side AB is alpha, such that cosine of alpha, the cos of alpha is 0.8. Find the diagonal BD and the perimeter of the rhombus ABCD. We are supposed to find the measure of this diagonal BD, the second diagonal BD. Okay, and the diagonal AC is given to be 18 centimeters. And not only that, you're supposed to find the perimeter of this figure. So what is the perimeter? It's the length of its boundary. Let's suppose you need to fence this. You would like to fence this. Okay. What do? You basically get the length of the fence that's equal to the total length of the boundary. That's AB plus BC plus CD plus DA. That's called as the perimeter. Okay. So we are supposed to find the perimeter of this figure, that's the rhombus. So for that, we need to know the measure of these sides, which is unknown. So first, let's draw the figure and try to mark what is known and what is unknown. So for you to find the perimeter, you need the measures of the sides. Okay, so now if you find one side, that is suffice because it's a rhombus. What is a rhombus? A rhombus is a figure, it's a quadrilateral, meaning a four-sided figure. Quadrilaterals, four-sided figures are called as quadrilaterals. Okay, so all these four-sided figures wherein all four sides are equal in measure. So that's going to be our rhombus, right? So if we know the measure of one side, that is enough. We will be able to know what is the measure of the other sides also, right? Okay. Now, you can ask me. So we've been dealing with only right angle triangles. Now, how to deal with the rhombus with trigonometry? Now, we need to spot out the right angle triangles in this. So does a rhombus have a right angle triangle inside it? Of course, yes. So just look at the diagonals. There is an interesting property in about the diagonals of a rhombus. Okay, so what is a diagonal? When the opposite vertices are joined together, so that particular line segment is called as the diagonal. The adjacent sides join together to form the sides of the particular quadrilateral, and the opposite vertices. Okay, opposite vertices, when you join them together, you get the diagonal, the line segment that's called as a diagonal. Now, the diagonals of a rhombus are perpendicular bisectors of each other. What do you mean by perpendicular bisector? Perpendicular means they are at right angles to each other. They meet at a point, right? They intersect at a point. AC and BD intersect at a point, meaning they meet at a point, right? Meeting is called as intersecting. At right angles, they meet. Okay, so the angle between these two diagonals at the point of intersection is going to be 90 degrees. Not only that, they are perpendicular bisectors, meaning they divide each other into two equal parts. Okay, bisecting means bi means two. Okay, two equal parts. They bisect each other, meaning they divide each other into two equal parts. So this BD splits AC into two equal parts. That's AO and OC are equal. And then similarly, the diagonal AC bisects BD into two equal parts. That is, BO is equal to OC. These are the things that we can comprehend from this figure. Okay, the measure of the side AC is given. That is 18 centimeters. So since AC is split into two parts, equal parts, we can have that AO equal to OC is equal to half of 18. That is 9 centimeters each, right? So we have this also with us. Now, what are we supposed to find? The first is we are supposed to find the length of the diagonal BD. Okay. So now let's see how we can find it. So we are moving on to the first subdivision. So the length of BD has to be found out. But here, the cos of an angle alpha is given. The alpha, where is it? Where is alpha? Alpha is an angle between the diagonal BD and the side AB. So AB and BD forms this angle alpha. So alpha is here. Okay. Now, if we are given the cos of alpha, so it is part of this right angle triangle AOB, right? Now, BD, is it part of any right angle triangle? Not really. But BD can be written as BO plus OD, wherein BO is a part of the right angle triangle wherein this alpha is there, right? So we have to convert things, unknown things, into terms involving things that we know. So we know cos of alpha, okay, and that particular triangle has BO there. So we can write BD as BO plus OD, right? Now, this OD again is not part of this triangle. So can we write BO in OD in terms of BO? Of course, yes. Since this BD is split into two equal parts, BO and OD will be equal. So I can write BD as BO plus again another BO because OD is also equal to BO. So BO plus BO, that is twice the measure of BO. Two times we are adding the same thing. Instead repeated addition is multiplication, we can multiply BO measure by 2. Correct? Okay. So that's what we are going to do now. So to find BD, we are going to find BO and multiply it by 2. So now how to find BO? So now let's consider triangle AOB. It's a right angle triangle. Okay, so and we know the cos of alpha there, that's given as cos of alpha is equal to 0.8. It is in decimals. Let's convert it into fractions. We can write it as 8 by 10, and this can be simplified and written as 4 by 5. Okay, so cos alpha, what is cos of an angle? It's nothing but the adjacent, the ratio between the adjacent side of that particular angle divided by the hypotenuse of the triangle that we are considering. Now cos alpha, the adjacent side is your OB. Okay, OB by the hypotenuse of this triangle is going to be AB, right? So now OB is 4 by AB is 5. Now these are not measures, these are parts. We need to keep it in mind. Okay, so 4, let's suppose we know that OB by AB is equal to 4 by 5. That is 4 is to 5. Correct? So now let us suppose that each part, the size of each part is X. So from this we know that OB is equal to 4 times X and AB is equal to 5 times X. Right? We all know this, right? You dealt with ratio and proportion. So basically it's 4 equal parts and size of each part we can take it as X. So your OB is going to be 4X and AB is going to be 5X. Okay, now how are we going to find this X out? That's the question now. Now, do we have anything that we know about this triangle? Of course, yes. We know in triangle AOB, we know the measure of AO. See, look at this. We have found out AO is 9 centimeters. And we also know that according to Pythagoras theorem, AB square is equal to OB square plus OA square. Why am I doing this? I need to find the value of X. Only then I can find the measure of this OB. I'm having only the number of parts it's been divided into and not the complete measure. Right? So I'm trying to find that out. So AB square, that's nothing but 5x the whole square is equal to OB square. Okay, OB square is 4x the whole square plus OA square. OA square is 9 square, right? So from this we will try to find the measure out of x. Let's see how to do that. So now we have, this implies 25x square is equal to 16x square plus 9. So now let's transpose the variables to one side. So I'm taking 16x squared to the other so that I can have all variables on the same side. So the 16x squared that's getting added to 9 will go to the other side with the opposite operation. It will get subtracted. So it's minus 16x squared is equal to 9 square. That's nothing but 81. So you have 9x square equal to 81. To find the value of x square, let's try to isolate the variable, take 9 to the other side, the numerical companion or the coefficient to the other side. This 9 is getting multiplied to x square. It goes as division on the other side. So 81 by 9, that's 9. So your x value is plus or minus 3. The ratio parts cannot be negative. So we are dealing with the length here, so it has to be only plus 3. So we have found the value of x as 3. Now we have OB and AB in terms of x. So let's quickly find the measure of OB. That's 4 times x or 4 times 3. That's going to be 12 centimeters. And AB is going to be 5 times x. That's 5 times 3 from here. And that is going to be equal to 15 centimeters. So we have found out OB, but we are supposed to find out BD. So we have a relation here that says BD is equal to twice OB or BO, right? Both are the same line segment. So BD is going to be twice OB, that's nothing but 12, 2 times 12, that's 24 centimeters. So now we have the measure of BD to be 24 centimeters. Not only that, we also know that AB is 5 times x, that is 5 into 3, 15 centimeters. Okay. So the first part, the BD has been found out. Now the second part of the question says find the perimeter of the rhombus ABCD. As I told you, perimeter is the sum of all four sides. The boundary, there are four sides here. So you add all four. So you get the perimeter, right? The total length of the boundary, right? So you have AB plus BC plus CD plus DA. Now you also know that we are dealing with a rhombus, meaning all the measures, all four sides measure the same. So BC, CD, and DA will also measure AB, right? So instead of BC, I can write AB. Instead of CD, I can write AB. And instead of DA, I can write AB. Okay, so repeated addition is multiplication. So instead, I can multiply AB by 4 instead of adding it 4 times to itself. Am I right? So this is nothing but 4 into, you know the measure of AB to be 15. So you replace, substitute that here, and then you get 60 centimeters. So the perimeter of this figure is 16 centimeters. So in this question, we saw how to apply a Pythagoras theorem and find the unknown side given the two sides. Not only that, we saw the property of the diagonals of a rhombus bisect each other perpendicularly. And then we found out the unknown measure of the side OB of this triangle ABO using cos alpha is equal to 0.8. We also applied the concept of the ratio. That ratios are basically parts of equal size, right? And then not only that, we also found the perimeter of this figure, wherein we saw what is a perimeter. It's a sum of the length of the boundary, right? So these are the things that we have seen in this sum today. So we have seen two sums wherein few sides, the measure of few sides and one or two angles are given, and then we are trying to find the unknown. So let's quickly look into the application of trigonometry. So it is used in marine science, wherein you will be able to locate the ships, the moving ships, and then the distance of the ship from the harbor and all that. Slowly, as and when you learn the heights and distances, you will be able to connect it with it. And then constructions, the civil engineering, wherein you construct the buildings. When you there, you have a lot of applications. And then criminology, in criminology basically you will be able to identify, it is used in identifying the the suspect, from where he has shot, the angle with which the bullet has moved in. There are a lot of things in it. So you just can do a bit of research to understand the applications better, so that it is so interesting and you will fall in love with the topic. And then in aviation, the position of the flights in the air from one point in time to another point in time, all these things. So as I told you, the more you go into the topic, the better you will be able to connect. And then not only that, to find the height of the mountains, okay, the mountain peak from the ground level, this is very, very useful. And then in gaming, so interesting, right? Many of you are interested in gaming, right? So in gaming, the way you shoot, the angle with which it has to move and all that, this is very, very important. It is applied everywhere, right? So it's a very interesting topic. Just start loving the topic, put in more interest, and with interest, whatever you learn, the learning will be the maximum. right? So, as I always tell you, please do not read through your math concepts, but please do practice. Practice makes a man perfect. Okay, so please do practice, do more of sums, similar sums that we've seen today. So just wait for my next video. My next video will be on standard angle values and more of trigonometry. Yes, I hope you enjoyed my video. Thank you. Keep practicing and all the best.